Good afternoon, everyone. My name is Domenico Giordano. I will present the contribution on title Accuracy of Energy Measures, the MyrailS project. Next one. I'm a researcher at INRI. Next slide, please. I'm a researcher at INRIM. INRIM is the Italian National Meteorology Institute. And next, please. A few words about MyrailS project. It was a meteorology project founded by the MPIR research program, and it finished last January. Here a list of outcomes from the project. Since such project involves many meteorology institutes, one of the focus was to the development of new calibration services for energy measurement functions. The devices presented before by Bart that are placed on board train to measure the absorbed and generated energy. So we developed calibration services for AC 50 Hz systems, for 17.7 Hz supply system, and even for DC supply system. And the upgrade was that such calibration systems are able to apply distorted waveforms to the energy measurement functions. Inside the project, we also developed the new tools for power quality monitoring, in particular for DC railway systems. And we patented an idea for the detection of arc event in DC railway system. We developed a methodology for the accurate determination of the power dissipated by braking resistors for DC supply systems, and accurate onboard determination of the energy saved by the eco-driving. Next, please. In this project, I will focus on the meteorological contribution that we try to provide to railway community, that is the calibration and the periodic re-verification of the energy measurement systems. As Bart mentioned before, it is required to measure, to have such equipment on board train to measure energy. And so it's important to evaluate the accuracy of such devices and to perform the periodic re-verifications. It's important to evaluate the accuracy of such devices, not only under steady state conditions, it means under pure sinusoidal or DC waveforms, but also applying distorted conditions or for DC plus ripple waveforms. And here you can see the contribution that I described, I present here. We developed new reference setups for laboratory and onboard calibration of EMF for AC system, and even for DC system. Next, please. Here you can see the structure for the calibration of energy measurement system, energy measurement function. For AC, both 16.7 Hz and 50 Hz system. The setup is constituted by 2 voltage and current amplifier. Such signals that are at low amplitude are amplified by voltage and current instrument transformers. So we are able to apply in the same time both voltage and current. So with this calibration facility, we can perform the calibration of the whole measurement chain that involves a transducer and the energy calculation function. Of course, we need a reference divider for the voltage measurement and the reference sensor for the current measurement in order to know with high accuracy the signals we are applying. And thanks to the low voltage generators, it's possible to apply not only sine waveform but even waveforms with distortions. Next, please. Okay, and here an example of a possible upgrade of the system that can be applied in the laboratory for the calibration of the energy measurement function, even on board. To perform the idea is to perform the calibration and re-verification, the periodic re-verification of the accuracy of the energy measurement function directly on board by applying a phantom power. So we apply voltage and current, but it's not a real power. But on the energy measurement function point of view, it's like to see the real power. In this way, we are able to apply reference signals that allow to perform the calibration. Here you can see the proposed setup for the AC calibration. Next, please. And of course, the system is able to generate the voltage and current dynamic that is required by the standards in order to evaluate in the point you can see here the accuracy of the energy measurement function under the dynamic operating conditions defined by the standard. Next, please. Here we move from AC to DC system. We developed a calibration facility able to generate voltage and current. You can see here that we are able to generate up to 5 kV and up to 2.4 kiloamps with an interesting high accuracy. And we are also able to apply disturbances like ripple. Next, please, to the generated signals. Okay, here the setup we have developed for the DC. We have a voltage and current, 2 channels. We generate voltage and current, and we apply in a synchronous way both voltage and current. And we generate the voltage by means of arbitrary waveform generation cards and amplifier that amplifies the voltage signals and the current signals. And we can also to apply such waveforms to integrated sensor that involves both voltage and current. So the peculiarity of this setup is that the current channel is floating from ground. And in this way, we can apply a phantom power that on the EMF point of view is the real power. Next, please. And here the amplifier we have developed for this setup, for the voltage amplifier and for the current amplifier, we are able to generate, as you can see, very high voltage, but for DC for sure is enough to reach up to 5 kV. The bandwidth for small signal is very high, so we can generate even ripple and transient events that could affect the accuracy of the energy measurement function. And on the right side, the current amplifier we have used for this setup. Next, please. And here the reference system that provide the traceability of the power for the calibration, the traceability to the national standard. For the voltage measurement, we use an accurate RC divider, and for current measurement, for reference current measurement, we use a wide frequency band with flux gate sensors. Next, please. Here you can see the capability, the possibility of the calibration facility to generate a real waveform. Here you can see the current and voltage we have acquired during one of the measurement campaign performed during MyrailS project. You can see in green the current. This is a commuter train, a 3 kilovolt commuter train. The measurement were performed in Italy, and you can see the voltage in red, the generated voltage, and in black the voltage signal provided by the EMF. You can see here that we can also generate the distortion, the transient event that can occur. And on the right side, you can see the result of the calibration for a specific case. Next, please. And the system for DC we have developed is also able to generate transient events like the arc, the conducted effect provoked by arc occurred between pantograph and catenary. Here you can see an example of voltage and current detected on board train during an arc event. With the generation system, we can also generate such events that on one side can affect the measurement of the power and energy, but on, next please, on the other side, we can use this generation setup to characterize new possible functionality of the energy measurement function. In fact, one idea is to integrate in the energy measurement function other functionalities other than energy measurements, and for example, functionalities that perform the power quality monitoring, and by exploiting the communication between the energy measurement system and on board and on ground, it is possible to collect power quality indexes in order to perform, for example, predictive maintenance. This is the case, for example, of the arc event detection. Such devices can be exploited to perform the arc event detection, to collect data, and maybe to perform a predictive maintenance for what concerns the pantograph and the quality of the contact between pantograph and catenary. And this is finally, you can see here the new metrological capabilities that some of the European metrology institutes have developed in order to guarantee the accuracy of the energy measurement system. You can see the new capabilities provided by LNI, that is the French Metrology Institute, by Fundación para el Fomento de la Innovación Industrial from Spain, and INRIM was focused on DC calibration facility, and you can see here on the last column the accuracy we can provide. Next, please. Thank you very much for your attention and for this great opportunity to share the novelties on the metrological side for the railway system. Thank you.
Thank you very much, Domenico.